Hi, this is Shipra and this is DSF Lab 2.
So for this week's lab, we're building on last week's lab. So last week's lab was the 555 oscillator. So for this week's lab, we're looking at logic gates. So the logic gate will take two inputs. The first input will be this push button, which is hooked up to this circuit. And when this button is on, we'll see this LED on. And then the second input will be the output of the oscillator circuit, which will be indicated by this blinking LED. And then based upon which one is on or off in terms of the inputs, we'll see how the output changes. So the first gate I tested was the NAND gate. So in the NAND gate, the output should always be on unless both inputs are on. So let's test this and see how it works. So right now we only have one input on, and that's the output of the oscillator circuit. So we can see that that is blinking, and then this output LED right here is always on, because even when this is blinking, we're either getting only one LED on or we're getting, both LEDs off. Now if I press the push button, that will indicate that both inputs are on. And so we can see this alternating, which means that when this LED is on, that LED is off, which is showing that when both inputs are on, this LED, which is the output, is off. So for the AND gate, the logic table basically says that both inputs have to be on for the output to be on. So if I just turn this on, the output LED is not on, because only one input, the output of the oscillator, is on, but because the push button isn't pressed, the other LED isn't on, so we're not getting both inputs high. But as soon as I press the push button, we see that this is blinking every single time this blinks, which means that in the combination of this and the other LED, we're getting an output that is high, which makes sense. Lastly, as a side note, the usage of the 220 ohms resistors, which are paired with each LED, is essentially to control how bright the LED is. And because we only want, because the LED is a diode, we don't want to provide too much current or it will burn out the LED. So putting the resistor in controls the amount of current that's going into the LED and allows it to light it at an optimal level.